finding particular integral when q of x is equal to sin ax or sin of ax plus b, cos ax or cos of ax plus b. We know that ypi is equal to 1 by f of d q of x, right? So we'll write this as 1 by f of d into sin ax or sin of ax plus b. In both the cases, we'll have the same formula. It may be sin ax or it may be sin of ax plus b. It may be cos ax or it may be cos of ax plus b. We'll have the same formula. So f of 1 by f of d sin ax. So which we can write it as 1 by f of d sin ax is equal to 1 by phi of d square sin ax, which is equal to 1 by phi of minus a square sin ax. For finding the particular integral, we have to select only the terms which are in terms of d square. We should leave the terms like d and constants. We should keep them as it is, right? Then we are replacing d square with minus a square. What we are doing is replace d square with minus a square. Here provided phi of minus a square should not be equal to 0. Ypi is equal to 1 by f of d q of x, and we wrote that as 1 by f of d sin ax. We took that 1 by f of d sin ax and we can write it as 1 by function of d square sin ax, which is equal to 1 by phi of minus a square sin ax, where phi of minus a square should not be equal to 0. So in short, we have to remember that whenever you are given sin ax, cos ax, sin of ax plus b, cos of ax plus b, you have to just replace d square with minus a square. You have to just replace d square with is equal to 1 by function of d square cos ax, which is equal to 1 by function of minus a square cos ax. In place of sin ax, you can also write sin of ax plus b. In place of cos ax, you can also write cos of ax plus b. And here the denominator should not be equal to 0. But there can be cases where the denominator is 0, right? Like phi of minus a square equal to 0. Case phi of minus a square is equal to 0. We'll have the cases where the denominator becomes 0, like example if I take 1 by d square plus a square, 1 by d square plus a square sin ax, or I can take the case 1 by d square plus a square cos ax. So this is equal to minus x by 2a cos ax, and this is equal to x by 2a sin ax. For getting this, again we use the same technique what we applied for the exponential term, like multiplying the numerator with x and differentiating the denominator and replacing them with the value, right? So here also I wrote the direct formulas, that is 1 by d square plus a square sin ax as minus x by 2a cos ax, and I wrote 1 by d square plus a square cos ax is equal to x by 2a sin ax. I'll show you how we are getting these formulae and why I am replacing d square with minus a square in this case. If you observe from this sin ax cos ax, if I differentiate sin ax once, then I'll get the answer as a into cos ax. If I differentiate it one more time, the d square of sin ax, then that will give minus a square sin ax. If you observe, d square is getting replaced with minus a square. D square is getting replaced with minus a square. That's the reason I told you that there, in short, we are replacing d square with minus a square whenever you have sin or cos. And see that case where the denominator becomes 0. We have written there 1 by d square plus a square sin ax. If I replace d square with minus a square, the denominator will become 0. So therefore, I cannot apply the previous formula. Then as we use the technique in that exponential, we have to use the same technique in this case also. We have to multiply the numerator with x and differentiate the denominator. So I'll apply the same technique here. Multiply numerator with x and differentiate denominator. So I'll get that as x into 1 by 2d into sin ax. I multiplied with x and I differentiated this denominator with a d. So I got 2d sin ax. Then I can write it as x by 2 into 1 by d sin ax. I already told you that 1 by d is the inverse operator and it does the work of integration. 1 by d q of x is equal to integration of q of x dx. I told you this earlier, right? So therefore 1 by d sin ax will be equal to x by 2 into minus cos ax by a. That's the reason you are getting it as minus x by 2a cos ax. In the similar way, we can also prove that 1 by d square plus a square cos ax as x by 2a sin ax. Now we'll see the problems based on this sin ax and cos ax. Solve problem 1. D square plus 3d plus 2 into y is equal to sin 3x. Given differential equation is of the form f of d into y is equal to q of x, where f of d is equal to d square plus 3d plus 2 and q of x is sin 3x. So again finding the complementary function first. So for YCF, consider f of d into y is equal to 0, where f of d is d square plus 3d plus 2. Then auxiliary equation is f of m equal to 0. Then we get that as m square plus 3m plus 2 is equal to 0. Then I can write this 2 as 2 and 1. So I'll get m square plus 2m plus 2 plus m plus 2 is equal to 0. Or I can also write the roots directly from this. Whenever the coefficient is 1, just put minus sign to this. Then I can write the root as m is equal to minus 2, m is equal to minus 1. You can observe that I'll get the same roots from this technique also. So m into m plus 2 plus 1 into m plus 2 equal to 0. So this gives m plus 2 into m plus 1 is equal to 0, which implies m is equal to minus 1, m is equal to minus 2. So roots are real and unequal. So therefore YCF will be equal to C1 e power minus x plus C2 e power minus 2x. We got the roots as minus 1 and minus 2. So therefore they are real and unequal roots. So we get YCF as C1 e power minus x plus C2 e power minus 2x. Then we'll find YPI. YPI is equal to 1 by f of d into q of x. So which is equal to 1 by f of d is d square plus 3d plus 2 into q of x. Q of x is sin 3x. So this is of the form 1 by f of d sin ax. So here I can say that a is equal to 3. In place of sin ax, I have sin 3x. So a is equal to 3. So as I discussed earlier that for sin ax or sin of ax plus b, cos of ax plus b, you have to replace d square with minus a square. So replace d square with minus a square. Then we get it as 1 by d square with minus a square. But a is equal to 3. So that becomes minus 9. As here there is a chance of writing a mistake that minus a square sometimes will be taken as minus a whole square. So that will be a mistake. So you have to put minus then a square. So minus 3 square, that is minus 9. So I'll write here minus 9 plus 3d plus 2 into sin 3x. Then that gives 1 by minus 9 plus 2. So minus 7. So I'll get that as 3d minus 7 sine 3x. Now I cannot solve it further by taking the term 3d minus 7. Why? Because that function should be in terms of d square. Then only I can solve the problem by using that particular technique. So for making this as a d square, I have to rationalize it. So on rationalization, 3d minus 7 into 3d plus 7 by 3d plus 7 into sine 3x. As for using the technique, you have to rationalize first, then the denominator becomes in terms of d square. Then you have to replace d square with minus a square. So this is equal to 3d plus 7 into 1 by 3d. This is of the form a plus b into a minus b, which is equal to a square minus b square. Right? So this will give 9d square minus 49 into sine 3x. Now I'll replace d square with minus a square. Replace d square with minus a square is equal to minus 9. 3d plus 7 into sine 3x by 9 into d square with minus 9. So 9 into minus 9 minus 49. This is equal to, now I'll multiply these terms to this. So I'll get that as 3 into differentiation of sine 3x plus 7 into sine 3x divided by 9 into 9. So minus 81 minus 49. So that becomes 3 into differentiation of sine 3x is 3 into cos 3x. So I'll get that as 9 cos 3x plus 7 sine 3x by minus minus. So that becomes 130 with minus sign. So 9 cos 3x plus 7 sine 3x by minus 130 is YPI. So therefore, general solution is y is equal to YCF plus YPI. So YCF we got that as C1 e power minus x plus C2 e power minus 2x, and YPI is 9 cos 3x plus 7 sine 3x divided by 130 with minus sign. This is the general solution for the first problem. Problem 2. Solve d square minus 4 into y is equal to 2 cos square t. 2 cos square t. Given differential equation is d square minus 4 into y is equal to 2 cos square t. It is of the form f of d into y is equal to q of t. Observe RHS. It is in terms of t. So therefore it is of the form f of d into y is equal to q of t, where f of d is equal to d square minus 4 and q of t is equal to 2 cos square t. And we know that cos 2t is equal to 2 cos square t minus 1. 2 cos square t minus 1. So therefore I can write this as 1 plus cos 2t is equal to 2 cos square t. So I'll write this as 1 plus cos 2t, or I can also write this as e power 0t plus cos 2t. Now write auxiliary equation. Auxiliary equation, that is f of m is equal to 0. It implies m square minus 4 is equal to 0. Roots are real and distinct. They are different. So therefore YCF is equal to C1 e power 2x plus C2 e power minus 2x. We got YCF as C1 e power 2x plus C2 e power minus 2x. Now we'll see what is YPI. YPI is equal to 1 by f of d into q of t. Sorry, if you observe here, yes, we wrote that in terms of t. So therefore YCF should also be in terms of t. Right? So we'll make it as C1 e power 2t plus C2 e power minus 2t. We have to make it as 2t, not 2x. Because if you observe RHS, it is in terms of t. So here I wrote ypi is equal to 1 by f of d q of t, which I can write it as 1 by d square minus 4 into q of t. Q of t was given as 2 cos square t. I made it as e power 0t plus cos 2t. So I'll write it as e power 0t plus cos 2t. Then separating these terms, I'll get that as 1 by d square minus 4 e power 0t plus 1 by d square minus 4 cos 2t. Then ypi is equal to s. For the exponential, when q of t is an exponential function, we'll replace d with a, and for the trigonometric function, sine or cos, we'll replace d square with minus a square. So I'll write here once again 1 by d square minus 4 e power 0t plus 1 by d square minus 4 cos 2t. Here a is equal to 0 and here a is equal to 2. So therefore in this case I'll replace d with a equal to 0 and here replace d square with minus a square is equal to minus 4. As for the exponential case, we have to replace d with a, and for the trigonometric case, that is cos and sine, we'll replace d square with minus a square is equal to minus 4. So this will be equal to 1 by 0 minus 4 e power 0t plus 1 by s. D square should be replaced with minus 4, so that becomes minus 4 cos 2t. Therefore, ypi is equal to minus 1 by 4 minus 1 by 8 cos 2t. This is ypi, right? Hence, general solution is y is equal to ycf plus ypi. Ycf, we got that as c1 e power 2t plus c2 e power minus 2t plus ypi. Ypi we got that as minus 1 by 4 minus 1 by 8 cos 2t, which is the general solution of the given non-homogeneous linear differential equation.